All right, graphing. Now, we'll do this in two different ways. One is I just want to think about exponents because that's really the point of logarithms is exponents. How could I rewrite this in an exponent form? If you think about it, the base is 5, so 5 to the, well, let me re-say that. I don't want to really convert it to an exponential equation. I want to think about what's the inverse of this function. That's really what I want to get at. What's the inverse? And the inverse of this function is the exponential function y equals 5 to the x. And that should be easy for you to graph by now. You should know, okay, 0, 1, that's really about all I have to do. 5 to the 0 is 1, 5 to the first is 5. I know that I'm going to get a graph that's exponential, so it should look something like this. Okay. Now, if I want to graph the inverse of that function, then I can graph the log of that. And so instead of graphing 0, 1 and 1, 5, I'm going to switch the x and the input and the output, the x and the y, so that it's 1, 0 and 5, 1. So 1, 0 and 5, 1. Instead of having this horizontal asymptote here, you see we're going to have a vertical asymptote here. And so this turns into the function y equals log base 5 of x. So that's really what we're doing with logarithms, is we're going to think about the exponents. Now, if you go back and want to do this on a calculator, you can, or I will show you in Desmos. So we can just type in y equals, to get a logarithm, we're going to need a function, and they do have a log base a here. So I can do log base 5 of x. And you can see we have this similar graph. You see we have the x-intercept of 1, 0 here. We have the y-intercept of 5, 1. And it looks similar to my graph here that I have with the green. So, quick summary. I've covered two things here before we move on. I've covered how to evaluate logarithms when they don't come out evenly. You've really got 3 different options you can use. I've now hit graphing logarithms. You can use a calculator to your advantage. I really do want you to understand the relationship between inverses of exponentials and logarithms. Last part, we're gonna keep kind of beating this dead horse of looking at transformations and how can I transform graphs. Again, you see a log base 6 of x. That's the parent function. So the parent function is log base 6 of x. What is happening here? Well, we've got two things. We got the plus 3 and the minus 4. Plus 3, what's the plus 3 going to do? Well, it's inside the function, so it's going to move it left 4. And the minus 4, sorry, not left 4, left 3. The minus 4 is going to shift down 4. So if I was going to do a quick sketch of this graph, I would draw the x and y axis. I know normally I've got a vertical asymptote for my logarithm, and I have a point at 0, 1. I said 0, 1, I meant 1, 0. Notice I kind of am ignoring the 6. It's going to affect the shape a little bit, but I'm not too concerned about that. So if it goes left 3 and down 4, so this is y equals log base 6 of x. And again, it didn't ask you to do this. I'm just doing it to show you. Left 3, it's going to move this vertical asymptote 1, 2, 3 to the left. And shift down 4. So instead of this x-intercept being here at 1, it's going to go left 3, 1, 2, 3. And instead of being here at this point, it's going to be down 4 from there. So 1, 2, 3, 4. It's going to be about here. And it's going to take off a lot slower as well. So it's going to come here. It's going to look something like that. So it didn't ask you to graph it, but I just wanted to show you how knowing these transformations really affects the graph. The left 3 moves this left 3. The down 4 is going to move your x-intercept down 4. All right, let's finish this up. How about this one? What's going on here? What transformations do I have? How are they affecting it? So hopefully you're seeing natural log and you're thinking log base e of 2x. Again, the e versus the 6, not too much difference in the shape of the graph. It's still going to be pretty similar. We're still going to graph it like that. The negative sign reflects, since it's on the outside, hopefully you're remembering that it reflects it vertically across the x-axis. The 2, it's on the inside, so it's going to be a horizontal stretch or shrink. Just like the adding and subtracting, it's opposite of what you might expect. The 2 is going to be a horizontal shrink. And that concludes this video. So 3 things we hit. 1 is evaluating when it doesn't come out nicely. We have to use our calculator. We can use the change of base formula if you want, or if your calculator has the capability, you can do that. Graphing, we're really looking at inverses of exponential functions. And then again, transformations work the same way. They've been working for a couple chapters now. Hopefully that answers your questions, and that's the last video for this section. I am going to leave off